Hi, my name is Abraham Daniels. I am the Senior Technical Product Manager supporting Granite. Today I'm going to talk a little bit about the Granite models and some of the cool things we're doing here. But before I kick off, maybe we just want to level set in terms of what the landscape of AI model providers really looks like today. So I think on the far right we have our closed frontier models, and these players are really focusing on large scale frontier models, chasing AGI. Now these are very powerful, but they're typically quite expensive to use. And the next bucket we really have are the open source large language models, really led by a couple, really impressive players in Meta and Mistral and DeepSeek. And they've been able to demonstrate that, open source models really can compete with, our frontier closed source models. And at the far left, we have what I like to call our open source SLMs, or small language models. And this is really where IBM is focusing and starting to double down as part of our Granite 4.0 roadmap. Now, may I ask why? So there's a couple things that kind of drive this decision. I think the first is, it's very expensive to not only host, but train these large scale models. Also, in terms of kind of scaling, obviously compute infrastructure is a massive resource that is difficult to come by. That only makes it more difficult to scale these models out. Also, from a customization or model tuning perspective, they are quite impractical when you think about the actual size of these models. A lot of the focus is really being able to enable, enterprise proprietary data sets as part of some of the models, and really focusing on use cases that are key to some of our enterprise clients, where focusing on large scale models really doesn't make sense, and really can be a hindrance. And then, of course, slower inference speeds in terms of the scale of these models. With the introduction of ever increasing context windows, it only becomes even more difficult. And then lastly, just there's really a cost performance imbalance. So as models get more and more performant, we're starting to see that independent of model performance, cost doesn't always make sense, where you'll get incremental improvements while we're having astronomical jumps in both input and output costs for some of these models. So again, back to Granite, we've really kind of focused on a couple of different things within our Granite model family. So of course we have our workhorse Granite language model. This really gets a lot of the shine, but it's also released alongside a couple of multimodal models in our vision and our speech. Keeping in line with IBM, as a trusted advisor, we have our guardrail models, and then of course our time series, which have over, I believe it's 4 million downloads now on Hugging Face, and as well as our powerful embedding models. And then we're also supported by our accelerator and geospatial models. And really the focus, or the kind of pillars that we've tried to align with when building our Granite models, are ensuring that we are open. Now, what does this mean? So we define open by no nonsense licensing. So Apache 2.0 licensing, and a lot of both open source players on the large scale and small scale will release models under the guise of open, but you'll notice that there's very bespoke licensing requirements associated with that, whether that's naming conventions have to be used as part of releasing the model. So the idea is here, we just want to make it available as widely as possible. Next is performant. So just because they're small doesn't necessarily mean you have to sacrifice in performance, and performance in the form of specific capabilities, as well as unique models. From a reasoning capability that's come out, so we've been able to drive that as part of our smaller model landscape. And then again, just balancing this all with performance, cost, and efficiency. And lastly, trusted. And this kind of means a couple different things. We focus on trust from a guardrails perspective, and then also making sure that the data that underpins our model, is rigorously evaluated and aligns with not only legal but ethical requirements. So maybe let's just double click into some of these a little bit. So when I say open, as I outlined, really no nonsense licensing. So all of our models are released on a Hugging Face under Apache 2.0. So all the weights can be pulled down and used as you see fit. But we also work with a number of different partners, and working with these partners, we want to be able to just make, again, Granite as accessible as as possible. So whether that's working with the llama so that you can work locally with our models, or some of the hyperscalers so that you can have an inference point independent of what your infrastructure looks like. So again, keeping in line with open, I mentioned data earlier. So all of our data sets used to train our Granite 3.0 model, and this will be the same for our 4.0 model. You can go take a look at our technical paper, and we've outlined each data set line by line as part of our commitment to being transparent as part of what goes into our model. And then again, this has just been something that not only is kind of been the focus of Granite, but has kind of led to some of the cool, I guess, features that we've had as part of Stanford Index, as well as just being able to demonstrate that we're a trusted advisor. And keeping in line with that, so the Stanford Index or Stanford Transparency Index is really focuses on not necessarily the what is outlined, but the breadth of your model transparency. So it kind of ends up in three little buckets. So the first is upstream. So that's really, once the model is released, do you support this with particular recipes or guidelines? The model, so do you outline model architecture, what's used as part of the training, and then downstream. So how does the actual work that goes into the model, how transparent are you with respect to that? So as part of the May 2024 release, we see that we've positioned ourselves as fourth overall ahead of some major players like Meta, Mistral, and OpenAI. And what's really cool here is we've actually just submitted another bid as part of the upcoming release for mid-July, I believe, late July, for the next Transparency Index. So we're really just hoping to continue to drive transparency as part of our Granite roadmap. So maybe let's just pivot to performance. So again, as I outlined, from a capabilities perspective, so our Granite language models out of the box support multilingual for 12 languages. They also support code as part of a unified model, all trained on roughly 12 trillion plus tokens. Some of the cool features we're starting to integrate into our models are chain of thought. So what's unique about Granite and with respect to how it's approached chain of thought is there's actually a toggle. And the reason behind that is not every question requires, a 10,000 token context, 10,000 token output. If you just want to know a simple question, then why have chain of thought reasoning? Also, a number of modality capabilities we'll talk a little bit about as part of how we start to perform in the vision and speech space. And then what's a cool feature that's coming out is called unrestricted or unconstrained context length. And what that really focuses on a new positional embedding that we've actually developed here at IBM that really allows us to have an infinite context window that's only gated by the compute or GPUs allocated to the model. And then just a kind of a really cool slide. So what this outlines is kind of what I mentioned earlier when you talk about performance versus cost. So on the far right, we have our Granite 3.2 8B instruction model. And these general code and math are some key benchmarks under MMLU, human eval, and GSM-AK. So these really are some core benchmarks that we evaluate our model on. And what you can see here is that when compared to GPT-4 that came out a year, just a year prior, we are either in line or doing better than a frontier model that is roughly depending on what you read, 1 trillion parameters. So I think this just demonstrates that you don't always need to have the the latest and greatest or the biggest model. It really depends on the use case that you're focusing on, and if you wait long enough, given the speed in which models are being released. What was a big, large-scale frontier model in 6 months to a year, may be able to get packed into an 8B or a 30 billion parameter model. And something I'm really proud of. So recently we've, as part of our multimodal kind of effort, we've released our both a vision and speech model in last month. So our speech model was able to top the charts on the OCR bench, which really focuses on OCR capabilities and across handwritten text. And so it was number 2 overall, and really number 1 when it comes to models under 7 billion parameters. Sorry, I apologize. OCR bench is our vision model. And it came up number two overall, and number one when you refer to models under 7 billion parameters. And our speech recognition model, or ASR model, actually came number one in the ASR leaderboard, which it focuses on word error rate. So when you transcribe an audio to text, what is the error rate as part of that text? So, we were in the, I believe 5.8, can't really see the text, but what was phenomenal, again, not only we were first place, but as you can see, we also took the sixth place or the seventh place on the board too. So I think this is just a huge commitment from the multimodal teams in driving performance. And we're really excited to see what kind of performance we can get with 4.0. And then from the trusted perspective, like as I outlined, it was two kind of categories. So from the guardrails, we've developed a suite of Guardian models across a number of different sizes, from our 1 billion parameter inference to 8 billion. And they focus on detecting risks, not only in the input, but the output. So you can use it as part of a guardrail before you inference a model or on the output of a model. And what's really cool about these is, of course, they're suggested to be used as part of our Granite pipelines, but they can work with any LLM. They aren't beholden to our Granite models. And we've actually been able to, there's a Guard bench, which is a recently published leaderboard for Guardian models or Guard models. And as you can see, we host not only the top 4 spots, but the top 6 out of 8 spots. So, we actually are working with another leading benchmarking org to start to integrate our Guardian models into their pipeline to be able to, it'll be the de facto determinant on whether a model is safe. So the Guardian model will actually be the decision tree on whether a model is safe based on the inputs and outputs. And then again, from the data perspective, so all of the data that underpins our models goes through a really robust pipeline that starts with data acquisition or data identification acquisition. And as part of this acquisition process, we liaison with not only domain experts, but IBM legal, as well as IBM ethics and responsibility, so to ensure that we align with responsibility guidelines. Once we've identified and acquired the data, there's a robust pipeline of processing where data is annotated. As part of this, we really focus on language detection, HAP, as well as document quality. A key item is ensuring that we align with crawling guidelines via URL block listing. And then lastly, as like a final stop, we really focus on license detection. So what it really focuses on ensuring that data licenses align with the can-use list, so that we're not breaching any sort of contracts. And then lastly, the data processing. So this process is really filtering out for the items that we see shouldn't be used as part of data training, and then tokenizing before final model training. And so this is a kind of a cool slide. So what we demonstrated here is, so typically what we saw early on with the introduction of R1 DeepSeek is that the reasoning came at the cost of safety. So on the graph on the left, what you see here is that when you move from distilling R1 into Llama and Qwen 8B and 7B respectively, we saw a decrease in Arena, which is it's a evaluation that really focuses on difficult questions, and then the Palka, which is really an automated instruction following benchmark. So we saw here that not only did the evaluations drop when distilling down to a smaller model, but it came at the cost. It also costed us in the realm of safety. But when we pivoted and introduced kind of reasoning into our models in 3.2, we saw that not only could we increase performance, but we increased safety. So I think this is just a testament to maintaining safety characteristics as part of our model development lifecycle, and not sacrificing safety at the at the improvement of standard benchmarks. So all this to say that these kind of revolved around Granite 3, so our current class of models. So this summer, we're introducing a number of different models, as well as later in 2025. So the Granite 4 Tiny, which will really focus on running locally or inference scarce resources. Our Granite 4 Small, so this will be a little bit more. So this is a 30 billion parameter, 6 billion at inference. So this is kind of our general workhorse everyday model. This will kind of be the drop-in replacement for the 8B. And then later the year, we're focusing on releasing our Granite 4.0 medium. So this is a larger scale model for more complex tasks, and it'll be roughly 120 billion parameters, but 30 billion at inference. And the focus for this, 4.0 is really driving reduction in cost versus larger models, as we outlined, reducing memory requirements when it comes to actually hosting the model. So being able to use more consumer grade hardware as part of your hosting. And then, of course, given the updated architecture, being just much faster as part of your inferencing. And when I talk about updated architecture, so there's a couple things. So we're focusing on a hybrid design, so combining Mamba 2 state space architecture with transformers as well as MOE. Linear scaling, so this is really just to improve the efficiency of the training pipeline. I spoke to this a little bit earlier, the no positional coding, or NOPE, which is really a mechanism to unlock infinite context window and really only be hindered by the GPU capacity allocated to the model. And of course, efficiency focus. So, more efficient training, more efficient at inference, more efficient from the perspective of, compute requirements. So all this is coming down the pipe this summer. Really excited for this. And with that, I'll pause and I will hand it over to Gabe.
All right, thanks, Abe. Sorry, you caught me responding to a question in chat there. Cool. Well, so Abe just walked us through a lot of details about what we've built with Granite and why we've built it the way we've built it. So what I'm going to do is pivot to show it in action. I guess I should introduce myself as well. So I'm Chief Architect for AI Open Innovation, which really just means my job is to make sure that IBM's AI technology works well in the open source where developers want to use it. So what I'm going to show today is some actual use cases using Granite and how you can use it to get value today. So this is a combination of a collection of tools out of IBM, Granite at the heart of them, and also a collection of tools from the open community, not out of IBM, that Granite works well with together. So before I dive in here to actually show you what's on my screen, we're going to talk a little bit about what tools I'm pulling together here. So we've heard quite a bit about the Granite models themselves. You can think of them as the batteries that actually give the power to this whole system, because they're the ones that actually know what to do with the text and with the content. There are two other IBM tools that we're going to look at today. One called Dockling, which is a tool in the open source to convert and extract information out of any document format you can think of, whether it's PowerPoint, PDF, Word, a screenshot, handwritten note that you took a picture with on your phone. Dockling can shove that through all of its conversion pipelines and actually extract structured information in the form of Markdown. So if you have, for example, tables in your documents, those will come out as Markdown tables, all of which Granite as an LLM is able to then understand and make sense of. The other tool I want to talk to about today is called BAI. So it wouldn't be a 2025 presentation about AI if it didn't include the word agent. So the notion of an agent or an agentic application is really an application built where there is logic that orchestrates multiple interactions with an LLM to produce a final output. And there's a whole bunch of different ways that agents can be built. There's lots of different libraries out there to build them with. And BAI is a tool designed to bring all of those different definitions of an agent and all of those different frameworks that you can build agents with into one place so you can mix and match and experiment with them. So it's a really developer-friendly tool for accessing different agents. One of the agents out there that's really popular is called GPT Researcher. It is written by an open source community. Original author, I forget where he's from, but put it out there as open source, and it caught fire because it's actually really useful and good. And so what I'm going to show you today is an example of the GPT Researcher agent running inside the BAI agent platform, exposed through yet another open source tool called Open Web UI, which is a common UI that allows you to bind models and agents together to interact with them on your local machine. And all of that backed by Granite, running in Ollama, which is an inference engine for running models locally. So one of the things that Abe touched on is these models' size, that they are in fact small enough that you can fit them on a high-powered laptop or a small server node. I happen to have a high-powered laptop, so I'm able to run our 8B model seamlessly here with the long context needed to do a deep research task. So the first thing I'm going to show you is an example of using this deep researcher to do a task that has some sensitivity to it. Now, obviously, this is fake sensitivity. I'm not going to disclose private information here, but many people work with sensitive data every day. And one of the big concerns around LLMs, especially large frontier models that are hosted in the cloud somewhere, is sending any sensitive data off of your workstation and the risk that that poses to your data's security. So one of the beauties of working with a LLM that is small enough to run where you want it is that you can keep the actual LLM and all the data within your trust boundary. And in this case, the trust boundary is my laptop. So with this, I'll start walking you through what I have here. So you can see I gave a very simple report or prompt here. Now, this part I'm not going to show live because the actual conversion of the document is quite slow since it's 128 pages, but we'll get there. But I'll walk you through what happened here when I ran this. So the beauty of this researcher is I didn't need to do any complicated prompt engineering to tell the model exactly how to extract what. How to act as an agent. The agent itself actually has all the instructions baked right into it. So from my prompt, it was able to determine that it should act as a financial analyst. It was then able to create a bunch of subqueries based on my question and go off and search the internet and find a whole collection of different sources that would actually be useful. So the question I'm asking here is to compare IBM's annual financials against other large public companies. So it did that. It scraped, did a whole bunch of scraping, and then it was able to actually feed all that information that it pulled off the internet. We're still in the public domain here, and bring that together into a concrete report here that actually lays out a very nice story about IBM's historical financial performance. And I know nothing about financial analysis. I'm a software engineer by training. So having the actual methodology reported here was really helpful. And then having a side-by-side comparison of all the individual companies and how they performed relatively gave me very clear information. Okay, so up until this point, we're just purely working off of public data and public information. So there's nothing private or sensitive here yet. But now let's say I happen to be privy to an internal document or a draft of a future financial report. And I would like to get some actual insight on how to change the trajectory of IBM's financial direction. So I'm going to upload here this annual report document, which I did ahead of time, obviously. It's going to get converted using Dockling. It's going to extract as much information as possible as I can out of that, which is going to include things out of tables, things out of charts. And I'm going to give it a follow-on prompt here. So now I'm going to ask, given the analysis that you've already done against public information, add this private information and figure out if we can actually identify some key factors contributing to financial numbers lagging and what positive trends are we seeing in the details of the numbers that we could actually lean into as a strategic direction. And you can see from there that it's actually able to pull out a nice bulleted list of things that could be considered concerning and things then that we should lean into strategically, which not coincidentally also happen to correlate with where IBM is leading strategically. So from there, we've got a nice piece of analysis that kept our private data private and is actually something we can take action on. So then I can lean into what models are good at in general, which is summarization and repackaging of text. So let's say I want to distill all of this down into a nice pithy executive report that I can share, and then potentially an email draft I could send out. So I can ask the model to do that as well, continue my multi-turn conversation here. And now I've got, a mostly fits on one screen executive summary and a draft email that also mostly fits on one screen. So we've gone all the way from the public internet's worth of information plus 128-page financial report to strategic recommendations. And if I ran this workflow top to bottom, it would probably take on the order of 8 minutes, given 5-ish minutes to convert the PDF. So that's far less time than it would have taken somebody to compile all of this themselves, even if they were an expert in financial analysis, which I am not. So that's one example of Granite in action. But one example is great. we can build custom applications to solve single examples all day long. The real power of LLMs and agents comes in the form of extensibility. So I'm going to show you two completely different examples where I used exactly the same setup to do a very different task. So this is actually one that was relevant to putting this demo together, was figuring out how to glue together Open Web UI, which is the UI I'm using right here, with Dockling to actually get that big PDF converted. So it's going to look similar, but it's going to produce very different results. So rather than being a financial analyst agent, it decided to be a tech integration agent. And it went through the same process of browsing the web, aggregating sources, and then producing an output here. Now, this is an area where I am relatively expert. I know how to go off and read technical documentation. And yes, I absolutely could have produced this same information in a short amount of time using the internet. But this took 30 seconds, a minute, and I was able to get off the ground much faster, even in an area that I know quite well myself, by using an LLM to help me aggregate that information. And finally, just to show that this is truly extensible, and granted, I ran this a little while ago, so the dates are going to be out of date, but let's say it's time to knock off for the week, and I want to know what to do this weekend with my kids. So nothing to do with work. I want an event planner to figure out a weekend in Denver, which is where I live. So same process, and here we have a nice aggregated list of maybe a month out of date, a couple months out of date, of the actual events going on in Denver, grounded in local time and local space, and with a nice layout that helps me decide what to do with my kids. So this is one example of an agent that leverages a purely local model with long context to genuinely help me get my job done faster. And I frankly use this on the regular, just getting my job done. So that is our goal with Granite, is to meet people where they are, where they can be inside enterprises trying to get work done, and do it in a way that is, as Abe pointed out, performant and trustworthy. And that pretty much concludes what I have here. I think we have a couple of minutes left here to either take questions, or Abe, do you want to walk through some of the details of Granite 4? You're muted, Abe.
Happy to take additional questions. I believe we've got 2-3 minutes left.
If there aren't any questions, or while we wait for them to pop up in the chat, one thing that Abe touched on with Granite 4 that I am personally very excited about, having spent a lot of time down in the weeds of it, is the advantages that the new architecture are going to provide. For those of you not deeply in the know, a Mamba 2 layer, which Abe briefly alluded to, is a different model architecture than a transformer, and it's what allows for infinite context at fixed size of memory. So currently, as I'm actively trying to build out the Granite 4 support in some of our open source projects, I'm able to run the Granite 4 model at that number that Abe showed, almost an 80% reduction in memory usage relative to Granite 3 with comparable performance. So it's going to be a real game changer in terms of squeezing these big models onto smaller devices. And that's one of the things, even the demo I just showed, we've tried to have folks with less powerful machines run it, and it is difficult to get that to happen. So with Granite 4, this should be accessible to almost everyone.
And maybe just something in terms of the Granite 4 kind of the roadmap. I spoke earlier about a number of different models that were released. So the idea or the goal behind Granite 4 is to be more modular in terms of how we support specific use cases and capabilities. So what I mean by that is actually enabling adapters as part of the vision and language side of things, as opposed to releasing fine-tuned models or fine-tuned versions of Granite. So I think just in that same scope of inference efficiency, as well as reduced footprint, the Granite 4 roadmap specifically to the multimodal is looking to really support adapter modularity as part of our vision and speech capabilities. there are some questions.
Yes, I see one about, I just tried to answer one about the agent running in Ollama, and it's important to make a distinction between the actual logic of the agent and where the LLM is running. So when I ran the agent itself was running inside BAI, which is our agent platform that can run locally, and the model was still running in Ollama, and the agent itself was talking to Ollama, all running on my laptop. So that's the architecture there. I also see one about models on device, on smartphones. There are definitely lots of directions that that's going, and that is part of what we are aiming for with the Granite models, especially going into 4.0 with the lower memory footprint. There are a number of different inference engines that work on mobile devices. Mobile devices typically have different hardware and different ability to run different software. So it's an ongoing piece of work to ensure that our models are supported in all of these platforms. But it is absolutely a target. And from the fit of the model itself, it should fit very nicely into modern smartphones.
And then there's a question: is IBM self-published? I'm assuming this is referred to the benchmarks. So we've got twofold in terms of how we report benchmarks. So there are self-service, open source leaderboards in which we, run our evaluations, but the evaluations are rerun by the leaderboard owner to confirm or validate the actual performance of the model. So in terms of self-service, it is still validated, and we also do work with third parties for more, rigorous and robust red teaming and evaluations. So in terms of can you trust it? In short, yes. I think what we really need to hyper focus on is maybe having more use case or enterprise specific evaluations as opposed to the plethora of open source benchmarks that keep on popping up. There was one question: what type of interface were you using to talk to Granite, Gabe? I don't know.
Yeah, I answered that in chat, but the tool is called Open Web UI. It's free open source, as are many awesome AI projects right now. So you can just Google for Open Space Web UI, and you will find instructions on how to get that installed. It does require some Python chops to get it up and running. So if you can wrangle a Python environment and pip install it, you're off to the races.
Awesome.
And it's useful for things well beyond Granite as well. You can use it to access any model that you have running in Ollama, and you can bind it to other hosted models. And you can do things like plug in agent functions, which is what I have done here with BAI in my demonstration. So I was able to call BAI from Open Web UI as the front end, which then perform the agent logic to talk to Ollama running the model. So it's a whole chain of events, but pulled all together into a nice UI that I can just Command Tab over to and get my work done. I think that's all the time we've got.
I believe so.
All right.
Yeah. Feel free to close out. Oh, well, thanks for coming out.
Yep.
And if you have any questions, by all means, feel free to reach out. The best way to contact me is via Slack at Abraham. I'm happy to connect to continue any conversations.
Yep. Likewise, feel free to reach out. We'll hope you enjoyed the content. Bye.
Take care.